Hey everyone, I'm Alex Williams, the New Stack. Jason McGee is an IBM Fellow, Vice President and CTO in the Cloud Foundation Services Group at IBM. I recently had the chance to catch up with Jason to get a picture of IBM's perspectives about Docker and the container ecosystem. IBM is a sponsor of the New Stack's ebook series on Docker containers. Go to thenewstack.io to get your free copy of this one-of-a-kind 5-part series.
Hey, Jason here.
Alex Williams here.
Hey, Alex.
Hi, Jason. This is an effort on our part to kind of look at companies and how they began working internally and to help themselves think about containers. Now, IBM has been doing research for years and is very familiar with containers technologies. But with this modern movement that we're seeing, kind of this need for business acceleration. So we see, developer acceleration, and we see IT figuring things out and building out their infrastructure, but while trying to maintain, their relationship with developers and catering to what they're doing. Combining with this is open source movement and just the onrush of just so many ways for people to communicate now. So I'm curious about the IBM story, right, or as it relates to Docker and the container ecosystem with this kind of context.
So if we start with the past, I think, as you're probably aware, IBM has a pretty long history in, I guess what you would think of as kind of virtualization and workload management technology. How do we run multiple applications in shared infrastructure, going all the way back to, some of the seminal work around the mainframe and even work that we've done on Linux. And so for a long time, we've been thinking about, how do you package workloads? How do you run workloads side by side on a computer system and control isolation and sharing of resources? And so I think, the beginning of containers really, from our perspective, came out of some of those problems. And if you look at Linux in particular, in some of the earlier work we did, 11, 12 years ago, we were looking at how do we take Linux and take the Linux kernel and start to build into it some of the ideas that we had in some of the mainframe systems and in AIX and other Unix systems and put in the primitives that allowed us to have resource isolation, between different applications running on a system. And so IBM, along with Red Hat and some universities like Columbia, worked together on essentially what is now called C groups in Linux, which is, one of the defining kernel technologies that enable containers like Docker to do the things that we all love today. And so, the early days started out with looking at those problems. How do we do resource isolation? How do we do control? How do we do packaging of applications? And IBM played a pretty important role in getting some of those ideas into Linux. We're also looking at patches around how do we do kind of migration of workloads from one server to another. And some of these problems, I think, were really relevant for service providers for what we would think of as cloud hosting today, where we're running shared infrastructure. They were important to IBM. They were important to Google in those days, but they weren't really viewed as important to the broader Linux community. And so it actually took quite a while, on the order of 3 or 4 years to get some of those other ideas accepted into Linux.
Why was that?
I think it was because they were viewed as kind of, I hate to use the cliche term, but more kind of enterprise requirements or more requirements that were needed by a small slice of the Linux community. And so the broader Linux community really, didn't see the need or the priority of getting these things factored into Linux. And it wasn't really until, kind of the late 2000s, even into around 2010, that it became more recognized that having these level of controls and isolation built into Linux actually had other uses. Like imagine you're using your Linux system to do a bunch of builds, and those builds are consuming the whole box, and because of that, you can't even do simple things like logging in. And being able to kind of carve out a space to say, hey, this terminal or this program is more important or should have some preferred access to resource allowed you all of a sudden to have a system that could do heavyweight tasks like builds while also providing highly performant interactive access, right? And so it took a while for, I think, the broader community to see the value and for those patches to basically start to get incorporated into Linux, let's say 5 years ago, 5, 6 years ago. And so the early history is all kind of, setting the stage, I think, for the core capabilities that have become containers today. The near term then says, okay, with the advent of cloud, I think a couple of things happened. From IBM's perspective, our cloud strategy is based around this idea that clients will have their end state will be a mixed cloud environment. They'll have, off-premise public clouds, they'll have on-premise private environments, they'll have things in between, that they'll have this hybrid execution environment. And for that end state to be viable, you really need a pretty simple way to build applications that can move between those environments. So portability and packaging of applications became incredibly important. And then, of course, as a cloud provider, a public cloud provider, we need to be able to run a lot of applications at high density with high efficiency on this shared infrastructure to be able to offer it at a competitive price and to be able to operate it efficiently. And so, there was a renewed interest in, well, how can we run a lot of these workloads with lower overhead? And virtual machines are great, and we all understand the value that virtual machines provide, but you're running a full copy of an operating system for every client, right? For every tenant, and there's a memory cost, CPU cost to that. So I think in the last few years, we started to say, well, how can we leverage some of these things that are existing in Linux in a cloud context? And that's where at least our interest in containers started to reemerge, and we started looking at how can we use it as a way to deliver software, to deliver application software and middleware in the cloud, and then how can we provide container hosting environments in our cloud that allow us to give you both the development simplicity and the efficiency that we need. And that all was happening at the same time that the Docker guys were kind of doing their work. I think what the Docker guys did, which is, I think always a lesson to all of us, is they took some very powerful technology that had existed for a long time, for a decade, and they made it really usable and consumable by the average developer, which had been kind of lost along the way. I think, the core capabilities were built in, but nobody had really thought about, well, how do you get the average programmer to be able to exploit the power that's built into the kernel? And so Docker, I think, really helped explode the use case by just, democratizing or broadening the pool of people who really could take advantage. And so that leads us to today where, we, IBM, are doing a whole bunch of interesting things around containers, from our cloud container services, where we're really running truly kind of container native environments, like you just deploy and run containers as a first-class entity. And we're doing that in a multi-tenant way where, users can actually share resource. And we're doing that in ways that can exploit underlying infrastructure, like running on bare metal, so taking the hypervisor completely out of the loop and giving some performance and efficiency benefits. We're working on, of course, delivery of a lot of our middleware in that way, so delivering mobile and analytics applications and the like, prepackaged as containers, and also looking at the DevOps life cycle. I mean, I think a lot of Docker and containers right now has been focused around how do developers leverage it to build their apps. How do you do build, and how do you do delivery pipeline, and how do you do image management, and all those things become really important to make it real.
You were saying today IBM is, developing its cloud container service. And you also mentioned how, taking hypervisor out of the loop and using containers as a way of delivering middleware. What is that way you're looking at how to deliver middleware with containers?
So I think there's a couple dimensions to that. I mean, one is maybe initially it's how do you just package up software and use that as a delivery vehicle. So instead of giving people, installers or virtual machine images, you can give them pre-built Docker images. So as a developer, as you're building applications, it's easy for you to go consume the software you need in that way. But as soon as you do that, an interesting thing happens, which is you start to then think about, how do I look at the architecture of that middleware and reform the architecture of that middleware to take advantage of the strengths of containers? Because I think the other topic that's often intermingled tightly with containers is this idea of microservices. And while you can do microservices without containers, we have lots of great examples of that, and you can do containers without doing microservices, they actually fit well together. That architectural style is well implemented with a kind of lightweight, rapid mechanism like containers. And so part of bringing middleware to containers is also like, well, how do you think about how you reform and re-architect that software in a way that is more decomposed or decoupled into services or components, and then deliver each of those components? How do you support the life cycle? So like containers are really good today for stateless things. You can do stateful things with containers, but it's a little bit harder. There's other issues you have to go deal with. So how do you maybe break up the middleware into stateful and stateless components that can be packaged separately and lifecycle managed separately? So there's a real transition that happens as you really think about how to make that software available in a useful way.
What are some of the things you're learning about how do you break this software into composable pieces?
Well, one thing is that it's hard. It's actually
what
really...
makes it hard? What makes it hard?
So what makes it hard is maybe not directly containers, but when you have something that has a more monolithic architecture to it, sometimes you actually don't really understand all of the interrelationships and dependencies that have been built over time between different components of the system. And as you try to break that apart and isolate it and package it in a way that those components have their own life cycle, you discover all kinds of dependencies and assumptions. Maybe you made assumptions about directory layout. Maybe you made assumptions about the location the software is running on, or the configuration of the host, or things like that make it hard and to decompose that application and deliver it in this more neutral way. And so I think a lot of it is just rethinking the architecture of how things are built. That's
just complex in itself. What have been some of the processes you've been using to do that?
The processes that we're using to figure that out?
Yeah, like, to figure it out and actually kind of do it. I mean, like we profiled a travel company today, and they broke it basically down into tasks. They had this monolithic application, and then they took just pieces out of it, and they started creating these microservices environments.
Yeah, I mean, I don't think the approach is actually a lot different. I think that's a reasonable way to do it that we have implemented as well in many cases. I think the other dimension maybe is, so if you take, we're talking here about kind of containers and containerizing workloads, but if you view those containers as an element within a broader cloud platform where that cloud platform is providing services, part of the services that the cloud platform is providing is some of the horizontal concerns, so like logging, monitoring, authentication, deployment, capabilities to deploy new versions and do updates. There's all these kind of horizontal aspects, right, that in a traditional, let's say, more monolithic architecture, you might have solved all of those problems within the context of that application or that piece of middleware. But in a cloud context, what you want to do is kind of leverage all of the things, the services provided by cloud, and narrow down, your application to just being the kind of domain-specific or application-specific parts of the problem. And so part of this kind of rethinking or refactoring of capability is also that. It's like, how do you extract out all of the horizontal functions and leverage what's in the cloud? And if you look at what we've been doing around containers, that's part of what we've been doing. We've been building, logging services, for example, and monitoring services, and then figuring out, well, how do we integrate those with containers? How do we automatically grab all the logs from something running in a container and shuttle that off to a centralized log analytics system? And that's both useful in itself for new apps, but it also means if I was taking some existing middleware and bringing it into this environment, I can just factor out all of that functionality from the existing implementation and leverage what's provided in the cloud, right? And I think, if maybe we turn to community here for a second, I mean, that's why we're excited about the work we've been doing to try to form communities around containers, like the recent announcement at OSCON with the Cloud Native Computing Foundation, trying to look at that broader space that says, okay, well, containers in and of themselves are interesting, but containers combined with resource managers and orchestration and microservices and service discovery and logging and the other things really form a new platform on which applications can get built. And how do those things interrelate? That's, the next, I think, frontier that we're looking at is how do all these things start to come together in more interesting ways.
I asked you about middleware, and prior to that, you were talking about, how do developers leverage to build, the application? Tell me about that part of your strategy and how that encompasses kind of like what IBM is wanting to provide developers.
The way I think about it, the way we're trying to execute our strategy around it is that cloud is a platform on which applications are built, and that platform is a composition of a set of runtime models where containers are a really important one, but not the only one. We have start from code applications in a Cloud Foundry-like context. So we have runtimes, and then we have a collection of services, and those services span a spectrum from the kind of foundational capabilities I described, like logging and monitoring and operations and databases and messaging and the like, to higher level functions like Watson Cognitive. And so what we're trying to do is essentially provide this platform that provides the basic runtime execution capabilities, the management around that execution. So how do you deploy and scale and make highly available that application, and a constellation of services that you can leverage and reuse around those applications that allow you to more rapidly compose the solution you're after, right? So you're not trying to deploy and manage all the components you need, but you're really just deploying and managing the components that make up your app, and then leveraging a bunch of APIs for other things that you need to finish the solution. And then deliver that platform in a consistent way across both on-premise and off-premise environments. That's part of the reason why things like containers are so central to our strategy, is that it provides you that packaging mechanism, that portable characteristic that you need to be able to build that application in a way that you can deploy it across the variety of environments it may be needed in, right? And containers, I think, are really interesting in that way, not because they're the only solution we've ever had for portability. I mean, you could do portability with code. You can do portability with VMs in some cases, but it's the best blend, I think, of flexibility. Like you can do a lot of different kinds of applications in containers and maintain portability. You're not either constrained to a certain hypervisor or constrained to a certain programming model. Like if you look at something like a traditional PaaS platform like Cloud Foundry or Heroku platform, they're very opinionated programming models, which means they work really well for a certain subset of applications, but for other applications they don't work at all, right? And containers, I think, provide a nice blend, right, where you can do both. You can get a little bit of both, a little bit of flexibility, a little bit of speed and portability.
They've often been described as providing that single source of truth for the developer. And we've also seen the real development of more continuous integration and continuous delivery services that are part of that. I think that speaks to that constellation of developments that we've had over the past few years, and then the containers being a big part of that galaxy.
And it's interesting to me, like, a lot of these problems have been tackled in different ways. Like, if you think back, I don't know, 5 or 6 years to when SOA and web services were kind of the hot topic of conversation, I think they did a good job of thinking about kind of the API side and like how do you standardize the API for an application. But SOA didn't really say anything about the operational side, like how do you actually deploy and lifecycle manage the service. And I think what's really interesting about what's going on right now with cloud is that it's really looking at the end-to-end problem. It's looking at how the APIs communicate. It's looking at how you deploy and manage. It's looking at how you package. It's looking at how the DevOps tools are pre-integrated into the programming model so that really cloud platforms can provide the full set of programming APIs and tools you need to really build and run and operate things, right? And that's very different, I think, than what's happened in the past. I think solutions in the past have been more narrowly focused on one part of the life cycle, and you had to kind of figure out how to cobble together the whole thing.
It seems like that plays very well to the IBM story going forward, where we need these ways to build out this end-to-end environment is going to be the real thing that matters. And I guess it might be helpful to take the reader through a little bit about what you're thinking about as we move into 2016 and beyond that.
So maybe a couple of dimensions of that. I mean, I think the comment you just made is right, which is that the piece parts are not as important as how the whole thing comes together. And that's why, like, if you look at this from kind of a open community perspective, we're really pushing hard on the creation of truly open communities that define most of the key elements that a developer would touch, so that the applications they're building are open and portable. Because we think the value that the platforms are going to provide is how we actually take those, open implementations and bring it all together and deliver an integrated platform that can leverage open technology in a way that, maybe to say that the value is going to be how these things are all integrated together and how we can provide that end-to-end platform. And a lot of our focus going forward is exactly that. It's like, how do we bring these together? How do we integrate them? How do we take advantage of being able to have visibility into and control over an application throughout its entire life cycle, from code through build to deployment to production, through all the availability things, operational tools. Like, you have this incredible insight into the life cycle of the application. How can we actually leverage that to people's advantage so that it's easier, faster, to build and deploy applications? And so we're really focused on that, focused on production, real, highly scalable, highly performant, secure, flexible production environments around these technologies. Getting from from development, I'm just getting started scenarios, to real scenarios where people are leveraging these things, and doing it in a way that it can be accessible to a really broad population of people. Because I think a lot of the technologies we're talking about here are quite popular in a certain subset of the IT industry and need to be made available in an easier way for everyone else to be able to get the advantage.
So getting from dev to these real scenarios where they can leverage, where things can be leveraged to a broad group of people. Can you give me an example of some of those real scenarios?
I think the real scenarios are cases where where these applications that are being built are used in business important, business critical production settings. A simple example maybe is just look at the evolution we're seeing happening in Docker with containers. Docker started out, primarily, not exclusively, but primarily being used by developers early in the life cycle to build their applications, to test them. Most of Docker started out with a kind of single machine view of the world. It didn't really understand how to be deployed in a clustered environment, how to spread the workload around, how to handle networking. There were a lot of things that were not solved yet, and as we've been trying to move to those more real deployments, you've seen the emergence of, let's say, Google's Kubernetes work, where they look at, well, how do I actually do clustering, and how do I do pods of related containers, and the work we've been doing at IBM around, let's say, networking and overlays. You can actually have networking that spans multiple machines for containers. So everyone's been looking at what's the next downstream set of things that we need to really take containers from a thing that's very good for developers to get started with to something that becomes the operational tool you use to run things in production. And, how do you get your ops guys to have visibility into those containers and all of that? So there's this evolution that has to happen as the same application goes deeper through its life cycle and gets into production and gets into updating and patch and all the other things that have to happen in real applications, right? So
bringing that, these real scenarios to a business setting, right? Bringing the technology to the business setting is going to be, obviously more important. What are your guys' thoughts on actually, executing on that so you can provide, companies with that capability to have that business acceleration that should come when you're developing and managing applications at scale?
So I think we're bringing it to reality in primarily two ways. One is by building some of the capabilities that are needed that we're talking about into our cloud platform. So things like the container services that we've made available on Bluemix provide a runtime hosting platform with some of the characteristics I described, with elasticity and HA and automated deployment and all the things that you would need to get to a production thing. So partly it's through actually delivering cloud services that have the characteristics we're describing. The other key dimension is the work we're doing around driving the community, the container community, towards common answers to some of these problems. Because one of the great blessings and curses of containers right now is there's a lot of overlapping or competing open solutions to common problems. And so the work we're doing with OCI, with the Open Container Initiative, with CNCF, work we've been doing in partnership with Docker and Google and others, is all about how do we drive us towards some common open solutions to these problems so that there will be less differences in different, let's say, cloud provider environments in how these problems are solved. Because all of these things bleed in some way into the developer, right? They're not all of these things are completely invisible behind the scenes to the developer. They actually affect how you build the app, how you package the app, what assumptions you make. And so, we're trying to drive the communities towards common solutions while at the same time we're building services that people can leverage in hosting those applications on our cloud platform.
Is there anything else you'd like to add before we go?
This is a pretty vibrant space that we're in. I think the next really interesting wave is going to be how does the Cloud Native Computing Foundation actually materialize? A great fanfare in its launch, lots of work to do to actually make it an effective thing. But I think if we can pull that off, we're on the way to really defining what the future application stack is for millions of developers in the future, right? And I think it's pretty exciting to be in.
That's an interesting matter. And, the Cloud Native Compute Foundation comes out of, in many respects, come out of Kubernetes, right? And what that open source project and how that open source project developed, right? What's interesting about it, how it really abstracts the infrastructure. So we can create this application-centric environment, right? Someone provocatively asked me this question about, well, does that mean that this new architecture really is the new OS? And further, it makes me wonder, we talk so much about monolithic applications, right? And how these platforms like CNCF are could potentially help, make these applications, help companies develop microservices and use container technologies and scale them and so on and so forth. But then I wonder, well, the Linux kernel has been around for a long time, and many people would consider that a monolith as well. And what does that mean? So what does this mean as well for the Linux kernel itself?
Yeah, it's an interesting question, and maybe it's one of the great debates in the microservices world is like what is the scope of a microservice and how micro is micro and what should be in it. I do think though at a higher level things like CNCF and other communities, but CNCF is probably a good analog for it, is defining the kind of modern cloud-based or distributed operating system. Right, and a lot of the functionality we're talking about is things that you might have historically thought of as operating system functions distributed across a distributed compute infrastructure. And I think that's actually really exciting. And it's interesting. Like next week, is LinuxCon and ContainerCon and MezosCon and all this other stuff. And it's an interesting, just representation of what's actually happening. All these things are having to come together to define what the cloud operating system looks like. And operating systems have always been the interface boundary that said, what's an application? How do you build my applications? That's defined by, in a lot of ways, by the operating system. And so I think that is ultimately what's happening here. But it's a very different beast than traditional operating systems, much less controlled by a single entity or defined in a monolithic way, right? I mean, much more of a federation. And I think on that new operating system, microservices as an architectural style is the kind of dominant view of how the applications will get built. It's not the only way, of course, but I think it is the one that's being optimized for. And microservices, I think, is much less about technology and much more about how people work, how you break down problems into chunks that can be rapidly built by groups of people. It's more about optimizing the velocity of development for a group of people than it is about technology, right? Technology supports it, but it's really about solving the problem of how we build fast. And so, that's pretty exciting to me, and I think CNCF will play a role for sure, or at least I hope it does, as we try to form it. And that's why I think like Kubernetes is one of the key components that are getting contributed in there, but it's not the definition of the space. The space is broader than that, and there's lots of other prior art that I think will contribute. The Mesos guys announced they're in there on the resource management front. IBM has a lot of prior art with things like platform computing in the resource management and scheduling space that will contribute into that. There's microservices topics like service discovery and networking and other things that all have to get addressed. So I think it's going to be, hopefully the place where a lot of this comes together into something more cohesive across the whole life cycle.
thanks so much for your time. It's an interesting conversation.
Yeah, absolutely. Yeah, it was great.